All right, so the next thing I want to show you guys is virtualization. That is breaking a firewall down, a physical firewall down into logical firewalls. All right, so let's bring up a topology for that. Have it over here. Yeah, this is a good one. I want to show you a physical and a logical setup. So what I want to do is I want to have two departments, let's say the sales department and the marketing department. Both departments want their own firewall so that they can manage it, they can control the rules, they can do whatever they want to with it. But physically, I only have one physical firewall. What I have the ability to do with a ASA firewall is to break down the firewall into multiple logical devices. What's a logical device? Is basically breaking the physical firewall down in such a way that it is treated as two separate firewalls. So although my physical setup is like this, where if you follow the interfaces, ASA Ethernet 1 is connected to what? R3. Ethernet 3 is connected to R4. 0 is connected to R1. 2 is connected to R2, and R1 and R2 are connected to each other. This is your physical layout. So I have a single firewall, but what I want to do is I want to create a logical firewall, a virtual firewall. And when I create it virtually, I can assign it different interfaces. So I'll create a firewall, firewall 1, which will have two interfaces assigned to it, E00 and E01. I'm going to create another firewall with two interfaces again, E2 and E3. You get my point? Good so far? So although physically it's a single firewall, logically I have two firewalls with two interfaces each. That way, the traffic flow, let's say R3 wants to communicate to R4. This guy wants to communicate to R4. The physical, if you take a look at the packet came into ASA1, it would be able to send it to 4. But logically, what's happened is I've broken it down in such a way that the firewall 1 does not have connection to firewall 2 directly. It needs to forward it based on routing to router 1. Router 1 will send it to 2, 2 will send it to 3, and the firewall 2 will allow it based on the ACL rules to come back into R4. So the traffic flow will be like this. Understood? Good. So how do I do it? The first thing that I need to do is change the mode. The default mode of a firewall when you get it from the factory is single mode. That's the one that we have been running in our classes up to now. What I want to do with that single mode is break it down into multi-mode, which allows us the ability to break it down into different virtual firewalls. Understood? All right. So I'm going to set up a different topology. My objective, my physical topology is going to look like this. The one that you see on this side. Logically, I'm going to create this. I'll show you how to do that. Once we're done with that, we'll take a look at a more complex scenario where we do a little bit more in terms of virtualization. Right now, I'm just doing it based on physical interfaces. Then I'll show you how to create sub interfaces as well. First thing, I'll save this over here into your folder. Let's go to your Eve, stop these interfaces or these devices over here. There you go, close it. Security context. So this is the topology that we were looking at I'm going to fire up these firewalls and the routers. Let it come up. So while it's coming up, as I said, by default, the mode that the firewall is in is called the single mode. In order to go from single mode to multiple mode, I need to issue a command called mode multiple. Once I issue this command, it is going to reload the device. I'm going to lose the config of my existing firewall if I had any, and I get rebooted. When I get rebooted, I get put into this context known as the system context. All right, the system context itself is a non-usable context. You cannot run any traffic through it. It's a context that allows you the ability. It allows you the ability to create other contexts, but no traffic will run through it. It does not have the ability to assign any IP addresses to any of the interfaces. But the system context is where you create the other context. What do I mean by create the other context? To create the context, I need to specify I'm creating a context called sales. And the sales context has two interfaces, E00 and E01. So I don't have a firewall with 4 interfaces. I have a sales firewall with 2 interfaces. Similarly, I'll create another one called marketing, which will have 2 interfaces, E2 and E3. That stuff, creation of the context, is done in the system context. To create a context, I need to allocate it in interfaces. Plus, I also need to tell it the name of its config file. You know how you have a startup config file for a device? It's a single startup config file. But with multiple contexts, each context should have its own startup config file where it can store the configs. So I need to specify my config file name for this context and another config file name for this context. Understood? So this is what I need to do to create a context. All good? So if I have sales and mark, also know that you also have the system context, which is the context that you will create the other context from. So let me see what my state of my firewall is. It's in multiple mode already. So rather than doing this, I'll say mode single. And I want you guys to see it from scratch. So let's say I had a blank firewall that I want to bring up, and from that point on, I'll do the mode multiple so I can show it to you from scratch. In the meantime, you look at your topology over here for the routers. I want router 1 to have 192.1.10.0, another interface 192.1.12.0, and then router 2 has 12 and 20. They will share the resources in terms of memory and all that, yeah. CPU cycles and all that. Even the connections. You can limit the connections, but by default, it's first come, first serve. So let's do our routers. Let's configure our routers. Router 3 has 10.30.30.0. Default gateway should point to .11. Router 4 has 10.40.40.0. Default gateway should be 21. Let's see what it has, if they're configured or not. R1 seems to be configured. show IP interface brief, 10.10.10.1, 10.12. Am I running a routing protocol? Okay, I'm running a routing protocol, so it should be up and running. Router 2, 10.12 and 10.20, running the routing protocol. So if I do show IP route EIGRP, I should know about the 10 network. If I do the same thing on here, I should know about the 20 network. So my outside network right now is set up properly. Oops. This guy over here is routing. Now let's set up the insides and see if their default gateway is pointing to .11. I'll also enable telnet so I can demonstrate telnet to you guys. See if these guys have telnet already. Absolutely, I'm not giving you any redundancy with security context. All I'm doing is giving you the ability to virtualize it. So rather than buying 2 firewalls, I get 1 firewall. The firewall goes down, there's no magic over here. The physical box goes down, it's gone. So context by itself, there is no redundancy. There's telnet enabled on R2. Telnet enabled over there. Telnet over there. Telnet over there. So on R4, show IP interface brief, have the 10.40.44.4 network, and a default gateway that should point towards 40.40.21. Ten 30.30.11. Good, right? So let's see what the firewall is. It's now in single mode. Mode multiple is what I'm going to do. And as I said, it's going to erase the config or blow the whole thing up and come back up in the multi-context mode. What mode will I come in once I do the mode multiple? What mode will I be in? The system, yeah, sorry, which context will I be in? I'll be in the system context. So multi-context. It allows you the ability to break down the physical ASA into multiple virtual firewalls. You need to change the mode from single to multiple. The command used is mode multiple. It requires a reboot. When the device reboots, it will be in the system context. This is a non-usable context. It is used non-usable context for data. The purpose of the system context is creation and management, or creation and allocation of resources to the context. The actual configuration of the context is done within the newly created context. All right, clear guys? So I've done the reboot. Now I'm in the system context. What's the first thing that I need to do over here? Create the context. How do I create the context? Let's create sales and marketing. So creating the context. As I said, to create a context, what do I need? Context, the name, it is case sensitive. I need to allocate interfaces to it. You take a look at my first one. Let's say firewall 1 is my sales. Let's change the name over here for you guys. And this is Mark. So sales will have two interfaces, E0 and E1. How do I do that over here? Allocate interface E1. The other thing that I need to do is I need to give it a config name. This is your startup config name, whatever you want to call it, sales.cfg. That's how you create a context. Let's create another one. Mark, I'm going to give it two interfaces. So right now I will have what? Two firewalls with two interfaces each rather than having one firewall with four interfaces. Everybody okay with this? Now the other thing that I would do is bring up the interfaces in the system context. Have that up. Because when it goes inside the system, in the context itself, the no shut, if the physical one is not there, it has issues. So I'll do this also over here. Completely what I'm showing you. You need to know everything that I'm doing over here. So you need to do it from scratch. Copy. So I go to the ASA, create my context. Good. And I'll bring my interfaces up as well. Good question, Asim. No, it doesn't override it. That's what this message is telling you. It tries to fetch it. So if it's already in the file, it'll pull the config from that file. So you won't have a blank ASA or blank mark. You'll have that with that configuration. The message is saying it could not find, right? Which is a good thing because that means you're creating a brand new ASA or brand new virtual firewall with a blank config. Okay, so keep that in mind. You want to have this message, otherwise you're probably pulling up an old config that you've done. The one more thing that I want to talk about over here, which is done by default, but I want you guys to know, be aware of it. So how many contexts have you seen so far that I've done? I have the main one, which is called the system, which is a non-usable context, right? Inside it, I created two contexts, sales, and I created marketing. Okay, I have E0 and E1, E2 and E3. Agreed? Yeah. So how many contexts do you guys see right now? Three. So you have system, you have sales, and you have marketing. Now there is another context that is required, which is called the admin context. The admin context is a usable context that you need to have. The thing about the admin context is, if you want to do any type of management in the system context, right now I'm going through the console port. But later on, I might not have access to the console port because the firewall might be installed inside the rack, inside my data center. So I want to be able to go into the system context remotely through telnet. So what I do is, because the system context cannot have an IP address assigned to it, you have an admin context, you assign the management interface generally to the admin context, and then you can telnet into an admin context. Once you telnet into the admin context, you can jump into what? The remote system context. If you don't have the admin context and you telnet it into, let's say, one of these lower end normal virtual firewalls, I can telnet in from here into sales. All right, but I would not be able to jump in from sales into what? System, because sales is a normal context. The only context that allows you to jump in from that remote telnet into that context into the system context is the admin context. So this is specifically for what? Allows remote management of what? Of system. By default, what Cisco does, it gives you a admin context by default called admin. You still need to assign it interfaces. Let me show you that. If I do show context right now, you'll see I have 3 contexts. Now this is not the system context. This is called the admin context. System you don't see, you're inside system. And you'll notice that against the admin, what do you have? You see this asterisk over here? That tells you this is the admin context. That asterisk is more important than the name. You can call it whatever you want, but the name admin is what makes it the admin context. Now over here, you would generally have the management interface assigned. So you have the ability to give remote telnet or remote management to the system context. I'll show you that, but by default, this is the context you would assign it MGMT and move from there. Good? Absolutely can. So that's the thing. Let's say you had a license for 2 contexts. Although admin can be used as a fully usable context, it, in terms of licensing, it does not count the license for the system. It does not count you against for a admin license. It only counts you for what? In our case, sales and marketing. So in reality, if you want data to flow through the admin, you can do that, and you can actually have 3 contexts, 3 workable contexts. You get my point, everybody? All right, so with that in mind, let's go ahead and take a look at what we've done over here. I have the 3 contexts. Now I want to be able to configure them. This part is done for me on my notepad as well, right? Configure the context. Let's configure sales now. To configure the context, I need to jump into the context. So change to context and the name, case sensitive. I want you guys to see what happens when I issue this command. Notice the prompt over here. What does it say? Cisco ASA, right? Change to context. I want to jump into sales. What does it say now? Sales. So that basically tells you that you're in the sales context. So if I do show run over here, interfaces, you'll see that I only have 2 interfaces over here. What 2 interfaces? E0 and E1. Those are the only 2 interfaces that I assigned. So I've broken down a big firewall into a smaller chunk of small units that I can manage. The naming of the interface, same right as system context, meaning what is called over there? Yeah, it picks the name from there, if that's what you're saying. E0 and E1, yeah, absolutely. Now you do have the ability to change it if you want to. I'll show you that with the marketing. We'll delete it and I'll show you another way of doing it. But by default, it'll pick the physical interface just the way you assigned it. Clear so far, guys? So now I'm going to configure it. Basic configuration that we've been doing. So E00 will have 192.1.10.11. The E1 will have 10.30.30.11. I'll point a default gateway towards router 1. And let's do some NAT and let's do a telnet so I can manage it. Basic configuration of a context, the same way that you would do a normal firewall. So E0, name if outside, it would set the security level to 0. IP address, let's say 192.1.10.11, based on this diagram over here. Okay. I don't need to do no shut because it's done under the system context. Name if inside, IP address 10.30.30.11. Done that already. Route outside 00, pointed to 10.1, which is router 1. Let's do NAT, object network. Let's say call it pool A. Range. Normal stuff, guys. I'm just showing it to you so you guys can see I'm not doing anything different inside the context. Normal commands that you would normally do inside a normal firewall. You guys remember all these commands? NAT, inside, comma, outside, dynamic. That's your NAT done. Let's allow telnet from the inside so that I can telnet into the firewall for management. Let's set the password. We will do that, which is basically your active standby and active, the failover coming up. So basic configuration, if you guys take a look at it, you guys agree? Nothing new that I've done under the interface or under the context. So let's check by doing it, pasting it over here. So I should be able to ping 10.30.30.3, which is the inside router, and leave 10.1 is the outside, or for that matter, 20 dot or 12 dot, what is it called, 12.2, I think. So my access is complete. Now, if I go to the inside device, which is R3, I should be able to telnet to R1 or R2. Let's telnet to R2, 12.2 from R3. No, once you do the no shut in the physical on the system context, you don't need no shut underneath the context itself. So I go to router 3 now. Telnet to 12.2. Show users. I should be translated to that pool of addresses that I had assigned. 192.1.10.186. Some address from there. Any questions, guys, at this point? Now, the other thing that I promised that I would show you guys, I'll go back to change to system, and I'll say no context mark, because I want to do something with mark that I want you guys to see. So the way I'm going to create mark over here is I don't want the marketing people to struggle with which one of the E2 and E3 is the inside and outside. I know, looking at this diagram, that E2 is the outside, E3 is the inside. So what I can do is, rather than using the physical name of it, when I create my context mark and I allocate the interface to it, E2, I'm going to say E2 is your outside interface, or out, just a name. So now the interface will not show up as E2, it's going to show up as out. So you have the ability to create an alias so the administrator does not need to guess. Oops. E2 was out and E3 was inside. Let's check the context, what's stuck. Yeah, E2 was out and E3 is INS. Now I can go ahead and do my config URL / mark.cfg. Good so far, guys? Everybody okay with this? Now let's configure it. I want to show you guys the difference. When I do change to context mark, you will notice under the show run, I don't see E2 or E3. Do you see that? Now the person, whoever is managing it, knows that interface out is the outside interface. So rather than saying E2, he has to say what? Interface out. And now he knows that out means outside. He can do that now. What is the IP address over here? On this guy, it's 20. Let's say 21 and 40.21 based on the diagram. So 20.21, and similarly, I'll do the inside interface. Interface INS, name if, inside security level set, IP address 10.40.40.21. Actually, I should have done it over here now. So here I call them out and INS. So when I do the configuration of the context, say I'm doing mark now. Admin context is created by default, yes. You can change it, but the default name of the admin context is admin. So this stuff I did already. I'm going to start the config over here, default gateway, pool, same thing. But let's say if you want to do a static for router 4, we can do that as well. Let me do the normal dynamic NAT, and then what I'll do is, instead of doing telnet here, we'll do object network R4 host 10.40.40.4 NAT it statically in comma out. Static, and put the IP address as what was it, 20.4, let's say. And let's say I want to telnet access to it, normal stuff. Access dash list outside permit TCP any to host 10.40.40.4 EQ telnet. Let's give it, just for the heck of it, so we can test it, we'll get ICMP traffic as well. And apply it. Normal stuff that you would do on a normal firewall. So I'm not doing anything different over here. So we start with a route statement. Looks good. So under mark. So now technically, because I've allowed access from the outside to 20.4, 20.4 is the public address for 10.40.44. I should be able to go to router 3, which is over here, sit over here and telnet into what? 192.1.20.4, which would lead me with my default gateway, send it to sales. Sales says 20 is reachable via R1. R1 sends it to 2. 2 sends it back to Mark. He translates it and allows it to come in over to R4. So essentially, I took this path over here. All right. So let's do that over here. Telnet to 20.4, which is R4. So I'm going to go all the way across through 2 firewalls to get there. Timeout, and then we'll do it again. In the meantime, I'll test ping 192.20.2. Oh, there's the issue. There's something wrong over here, 20.2. Oh, there you go. Now it came up. 10.40.44. That's strange. Show interface IP brief. 40.40.21 is down. Change to system. Ethernet 3. Oh, I forgot to do what? I thought I had done it on all, except for this one. So now it should work. Let's try it again. There you go. I'm on to 4. My interface was down. Now, the other thing that I also want you guys to see is, if you guys remember, did I enable telnet on this guy that he could telnet into your sales firewall? Remember, I allowed telnet over here with the password of Cisco 123. Let's see if that works. Let me show you where that config is. This config over here. This is on sales. You guys following? Yeah? So let's try doing that. So I'll go to router 3 and I'll telnet to 10.30.30.11, which is the firewall. Cisco 123. I'm in. Show run, I can see the entire firewall. So right now, if you look at the perspective that I now have telneted in from where to where? From here to sales. Can I jump into the system? No, why not? Because sales is a normal context. It's not a admin context. The only context that allows you that capability is the admin context. Let me show you. If I say change to system, command not valid in the current execution space, not allowed. Why? Who's the admin context? A context by the name of admin. See the star over here. So let's say I want to make sales the admin context. So what I can do is there's a command called admin context, and you specify the name of the context that you want as the admin. So now sales is my admin context. How do I know that? Take a look at the star. You guys see that? Now, I don't even need to log off. Just because I've changed the admin context to sales, I should now be able to change the system. Take a look. Now I'm in system. You get my point? So just by calling a context admin does not make it the admin context. At any given time, you can have one admin context that could be any one of them. And what's the command to do that? Configuring a context as an admin context. Just a command admin context, let's say sales, which is the name of the context you want to be the admin context. Good, everybody? Following along. This was a simple one. In this particular setup that I did, I broke down one box into two virtual boxes by allocating two interfaces to what? E0 was allocated to what? Sales. E1 was allocated to sales. Similarly, I had marketing. I allocated E2 to marketing, E3 to marketing, where I'm allocating an entire interface to a particular context. There's a limitation over here though. Let's say I did want my box, which has 4 interfaces, E0, E1, E2, and E3. I have these, what do you call it, 4 interfaces. I want to break it down, but the way I want to break it down is into a topology that requires 6 interfaces. So I want to do this. Outside, inside, plus a DMZ each. So each one of those contexts requires what? 3 interfaces, and I only have what? 4. Just like on a router, you have the ability to split an interface into multiple logical interfaces. You can do the same thing. Resources are automatically allocated. First in, first out. You do have the ability to limit them in terms of how many connections can a particular context have. By default, it's first come, first serve. So for example, you can say, I want marketing to have, at the max, have 5,000 connections. Okay, but RAM and CPU, you don't have any access to. It's just more about connections. How many connections are you allowing to a particular context? Got it? Jelani, that's your answer. All right, so what I want to do over here is this. So this one is done. I can close this. And now I want to do a more complicated one. So my end result is this. I want to get how many contexts over here? 2, but each one requires 3 interfaces. So I don't want to assign what? a physical interface because I'm going to be lost. I only have 4. So I do it based on sub interfaces. The other thing that I want you guys to see and see how I integrate it is with a switch. Generally, you don't have devices connect directly into the firewall. You have them connect into a switch. I connect into the switch based on VLANing. I'll map it over. So I want you guys to see how I'm going to map over this physical topology to this logical topology. Very, very important, because this is what you need to do on the exam. You can do that for the port channels as well. Yeah. You guys okay with this? You understand what I'm trying to accomplish over here? So the first thing that I'm going to do over here is stop my topology. Let's open the second one up over here, where I have my ASA connected to all these devices with these interfaces. So this is my physical topology. I'll start it up. So I have more devices over here. Missing 5. One, 2, 3, 4, 5, 6, ASA and switch. The routing on the devices I've done. I'll check it anyways. ASA is still coming up. While it's coming up, let's check the routing portion. Router 1 should have 2 sub interfaces, E00 configured as what? 192.1.10.0 on VLAN 10, E00.1, which is 12.0 on VLAN 12. Now, anytime you see a sub interface on your router side, what do you need to do on the switch side? So router 1 E00 is a sub interface. What do I need to do on this port on switch 1? Anytime you see an interface that is a sub interface, on this side you need to create it as a trunk so that the switch will send the packet along with the VLAN tags. So whatever VLANs are assigned to these 10 and 12, I believe. Okay. Allowed VLAN is not required because by default all are allowed con. But if you want to control it, you can say 10 and 12. Okay. So let's check. On R1, show run. Notice what I've done is E00 is broken down into 2 sub interfaces. One is based on VLAN 12. The other one is based on VLAN 10. 12 has an IP address assigned, 10 has an IP address assigned. And I'm running the routing protocol on it. Router 2 over here, again, the same concept. So again, the corresponding port over here on router, on switch 1, E01, because again, this has what? Sub interfaces, E00.1 and E00.2. I need to send the VLAN tags. So this has to be a trunk. I need to check that for both E00 on the switch and E01 on the switch. But before I do that, let's check and finish the routers up. So router 2 now. Show run. So again, the sub interface is created. Normal router on a stick that you learn in your CCNA class. Good. And to check the switch, show run interface E00 is a trunk, E01 is a trunk. So you guys are okay with this part of the network? Everyone, give me the go ahead, very important part over here to set this up. All right, done. Let's take a look at router 3. Router 3 is E00. It's a physical interface, right? When it's a physical interface over here, I don't need to put it in as a trunk, which is R3E00, which is this guy. It's connected to E02. It should be what? An access port in VLAN 30. Let's check that. Let's see if R3 is configured properly. It should be in the 192.168.3 network. Should be a normal access port in VLAN 30 on E02 of switch 2. I'm on the switch, so might as well check E02. It doesn't have it. So what do I need to do on this side? What VLAN do I need to assign this in? See that over here at the R3. R3 is E02 over here. For what VLAN? VLAN 30. So I'll say switch port mode access, switch port access VLAN 30. I'm taking care of my routers right now. So physical to logical mapping using sub interfaces on the ASA. So for the first thing I did was router 1. I have the config, so I'll just paste the config over here rather than retyping it in for you guys. So this is the config over here. I would have done a no shut on the physical interface, and then I ran EIGRP. Router 2 would have been very similar. This is 12.2, and this would have been 20. This is 20.2. This is done. R3 would be normal. What do I have on R3 as an interface? 192.168.3.0 with the default gateway pointing to 3.11. Very simple config over here for this guy. Not running any routing for him. (192.168.3.11) 3.11, no shut, IP route 0000. Actually, this is 3.3. Thank you. So while I'm doing this, I will also do my switch configuration on the 3 interfaces that I've shown you guys so far. Show run interface E0/0, 01, and 02. For 00 and 01, I'll put a description as well. Connected to R1. Sure, Prashant. Tell me if you have any issue anywhere, you let me know. But if you're trying to do it with me, that's going to be an issue. Try to learn it. So if you're trying to do it as I'm doing it, I cannot stop for that. Okay. You guys okay with this so far? By the way, this is going to be what? Now tell me what you need to do on router 4, on the router side. Needs to have an IP address on 192.168.4.x. I'll say 4.4. It's a normal interface. So the corresponding port over here right should be in an access port in VLAN 40. Agreed? So I'll show you the router config as well as the switch config. So the router config will be very similar to R3. I'm going to call it 4.4. And the second firewall I'm using 21 as the address, so 4.21. See? This guy I'm going to call it 21 on the 4 network. So 4.21, 4.4 is my address. You okay with that, guys? And on the switch side, this is on 0/3. This is the port R4 connects to on 3. And this is where you find that out. If you take a look at it, R4 is connected to what switch port? R4 is connected to switch 1, port 3. So this port has to be in VLAN 40. Everybody okay with this? So I've taken care of this, this, and this. Now again, R5 and R6, they're normal physical interfaces. So they will be connected into E10, R5. R6, E00 is connected to E11 because it's a normal physical interface on the router. This is again going to be an access VLAN, VLAN 50. And this guy is going to be an access port, VLAN 60. The IP address is 10.10.10.50.50.5, 10.60.60.5. I'm going to point a default gateway towards him, .11 and .21. Tell me if you guys are okay, I'll do the config. Yeah? All right, so right over here, R5 and R6, I'll just copy this part. R5 is 10.50.55, and the default gateway is 10.50.50.11. .10.60.66. Default gateway is 10.60.60.21. This part I think I've taken care of. I'll just check anyways. R5 show run 10.50.55 and the default gateway. Okay, and R6 10.60.66, 10.60.60.21 as the default gateway. Everybody okay with this? And on the switch side, these two ports here 1, 2, 3, 1/0, which is connected to 5 in VLAN 50. 1/1 6. Good, everybody. I did the surrounding devices right now, got them out of the way. So my topology around the firewall is done. Okay. What have I not done so far? The firewalls itself. Take a look at what I'm doing with the firewall. I needed to have 3 interfaces each. So what I decided to do was assign E0 and E1 to sales, but E1 I split it up into what? 2 sub interfaces, one for what? VLAN 30, the other one for VLAN 50. Just like I did on the router, I'm going to do the same thing for the firewall inside the system context. So the way you do that on the firewall, you make sure I'm in the right mode. I am in mode multiple. Show context is blank with just the default. I'm not going to go through that restart again. You guys understand that you just need to say mode multiple, reload, it will come into the system context. This one is already there. So the first thing that I'll do over here is bring my interfaces up. So my 4 interfaces are up, E00, E01, E02, and E03. Once that's done, I'm going to split up the interfaces. Which interfaces do I need to split up? This guy and this guy, correct? These two are splitting up from what? E1. E11 is assigned VLAN 30. E12 is assigned VLAN 50. So when the packet comes in from the trunk over here, it is going to come in with a VLAN tag of 30 or 50. Based on 30, I'm going to forward it to E11. If it comes in as E12, I'm going to forward it to, sorry, if it comes in with VLAN 50, I'm going to forward it to E12. Understood? And the corresponding port of this guy, this is a normal interface. Which VLAN do I need to put this into? It's a normal interface. Access port in VLAN 10. This E1 is a sub interface. So that corresponding port on the switch should be a trunk. So those are these two interfaces. I'll find out which ones those are. Let's check. It's easier to see it on the topology itself. So E00 is over here. E00 is 1, 2. And then E1 is 1, 3. So what I'll do over here for you in the notes first. So E0, 1, 2 is the connected to ASA. E0 should be in VLAN 10. E1, 4. Oh, hold on a second. It's 2 and 3. Yeah, 2 and 3. Sorry. 2 and 3 is ASA. E1. This is the sub interface one, the one that I split up. Right? So this has to be a trunk, just like the router ports. So anytime you have a trunk on the other side, I need to do this. So this is E01, which is a sub interface. That's why a trunk. E00 is a physical interface. That's why I did this. So over here on the switch side, let's knock that out. Ooh, I haven't done the other ones. I did it in Notepad, but I haven't pasted it. So let's copy the whole thing so everything is taken care of. Trunk rung 3, 4, 5, 6, and then E0 and E1. That's on the switch side. How do I do the same thing on the ASA? So this step, I would call it configuring the sub interfaces on the ASA. So the first thing you saw me do was good, bought them up. E01 is the one that I want to split up. So I'll create this sub interface called E1.1. What is 1.1 assigned to? What VLAN? 1.1, 30. And 1.2, 50. So this is the way I create a sub interface on the ASA. You get my point? So I bought the interfaces up, and now I've created my sub interfaces. If I do the show command again, you'll see the sub interfaces there. Understood how you create it? So when I go to allocate, now I can allocate the sub interfaces. Again, don't forget the switch side. Anytime you create a sub interface, I need to do what? A trunk. Next, Mark has E3, 2.1 and 2.2. 2.1 and 2.2 is a sub interface, right? So 2 over here, which is a third interface over here, connects up to 2.0. So E2 connects to 2.0, E3 connects to 2.1. So if you go over here on my switch side, this is the one that is trunk 2.1. E2 is a sub interface, which is 2/0. And this one is 2.1, which is connected to ASA 3. Now, ASA 3 is a normal interface in what VLAN? In VLAN 20. The sub interfaces, 2.1 is in 40, 2.2 is in 60, so that's why I had to trunk 2. But 3, I'm just putting it in VLAN 20. You guys understand that? All right, so let's paste this part over here. This is 20 though. Switch 1, those are the last two interfaces over here that I need to configure on the switch. And then my sub interfaces. How do I create my sub interfaces now? Two one is 40. 2.2 is 60, I believe. Let's check. 2.1 is 40. 2.2 is 60. So let's make sure I copy it. Yes, we'll use ASDM a little bit, Khan, for doing the VPNs, the AnyConnect and what do you call it? Pretty much for the AnyConnect, but I'll show you how to configure that as well. Same thing. You can use ASDM in the lab. But this type of stuff, if you know what you're doing, is much easier and much quicker to do it from the CLI. You have ASDM on the lab if that's what you're asking. No CSM, just ASDM. So ASA, I'll create the sub interfaces again. So right now I should have 4 sub interfaces, and now I have the 6 interfaces that I need. What are my 6 interfaces now? E0, the physical, E11, E12, E21, 22, and this guy. So 6 total interfaces. Now that I've done that, the rest of it is simple. Tell me, how would I do this? I want to create 2 contexts over here, sales and marketing. How many interfaces in sales? Which ones? E0, E1.1, and E1.2, correct? So let's assign them. So what I'll do over here now is create the context with the interfaces. So context sales, allocate interface E0, allocate interface E1.1, allocate interface interface and then the tell me if you guys are okay with this. And again, if it is misleading, over here, what you can do, especially for your administrators of these sub interfaces, I can give them those aliases. Remember, E00 for sales is out, E11 is DMZ, and E12 is inside. So they don't need to worry about, oh, E11 is inside, outside, or DMZ. So they will not see this as inside, outside DMZ. They'll see it, sorry, they won't see it as E3, 2.1, 2.2. They'll see it as, this is my outside interface, this is my DMZ interface, this is my inside interface. Because you as the overall administrator know the topology better than they do. You get my point? Questions, guys? Everybody good? I'll paste this, and the rest of the config is simple. They might, if you know it, it's good, right? So look at the question and do it based on what they ask you on the question. Everyone, guys, good? Yeses, please. I'll create my context. Show context over here will show me that sales has 0, 0, 0, 1, 1, and 2, and 2, 1, 2, 2, and 3. Now let's configure it. What is this? The sub interface, the virtual firewalling, used a lot. Absolutely used a lot. Especially when you want departmental control. Not only that, later on I'll show you the failover, the high availability, context plays a big part in there as well. You'll see that. So you guys are okay with this? Now let's go ahead and create them. Basic config, I'll create the 3 interfaces and then do normal stuff that you do. That's like saying I can create a VLAN. Why do I need to create a virtual device context? It's about management control. When you create a VRF, it's still the same management plane. You log into one router and you have everyone administering the same router. You have different departments, different buildings that are managing these firewalls. Yeah, you can give them complete control over their firewall so that they can control the rules. You cannot do that using a VRF because your management is still the same. You log into the same router, it's the same control that affects everyone else. You get it? So this is done. Let's do this part over here. So I'll do change to context sales. All right. So what do I have? Interface, I call them out. Name if outside IP address based on the diagram on the right hand side, say 10.11. Sales, I'll give .11s. Marketing, I'll give .21s. Interface INS, name if inside, IP address 10.50.50.11. Interface DMZ, name if DMZ. This one I do need to give a security level. IP address 3.11. Let's do a route outside 00, 10.1. Let's do a range for the NAT pool A 10.50, 1 and 10.200. Enough. And my internal object inside network is a subnet of 1050. NAT inside outside dynamic pool A object network R3 host 192.168.3.3. I want to translate as, let's say, 10.3 on the outside. NAT DMZ comma outside static 10.3. And let's allow access to it. Access dash list outside, permit TCP any to 3.3 for telnet, and we'll apply it. Access dash group outside in interface outside. Tell me if you guys are okay with this. Copy it. We'll change the context, create the interfaces, all 3, and natting is done as well. Now for the second one, which is marketing, it's 20.we-set21. Inside is 60.21. DMZ was 4.21. Default gateway is 20.2. And based on this diagram over here, 20.21, 1060.60.21, 192.168.4.21, default gateway 20.2, which is R2, pool 20.51 through 20.200, inside network that can use a pool 1060.60, and we'll create an object for R4, which is 44, map it to 20.4, and then give it access to 4.4 and apply it. So what are you saying is that you have this is your PE router, provider edge, and you have what? Your firewall over here as your CE router. Yeah. So that's okay. You don't need any ACL or any NAT. It'll be the outside address. This address. So BGP neighbor would be this, and for PE will be this interface. For this guy will be this interface. There's not going NAT is when the traffic goes through the firewall. You know, not on the firewall for itself. So if this was 192.1.20.10, that's what the neighbor would be. Okay. That's in to out, not to. There's a difference between to and through traffic. You need to understand whenever traffic originates or is destined to the firewall, no rules that apply to through traffic apply over there. When you're terminating the BGP on the firewall, it's to traffic, it's not through traffic. So NAT, PAT, all those type of things don't apply. So let's see if it works. What I'll do is to test it, I will go from R5 all the way across to this guy, whose public address over here is 192.1.20.4. And then I'm going to try to do this thing, whose public address is 10.3. I should be able to tell it this way and that way. I would also test my in to out NAT and out to in NAT on the other side, and the ACL as well. So let's try it one at a time. So we'll go to router 3 and telnet to R4. So I would telnet to 20.4, which is the public address for 4.4. Not happening. There's something wrong somewhere. Let's just try the pings. 20.2 is working. 10.1 is not working. I have an issue with routing over here. 10 and 12 is good. Oh, it's 10. It should be 20 over here. Now it should be okay. I went from R3 to R4. Not R3, I wanted to go from R5 because that would also test my Intel. Telnet to R4. So I came in, my R5 got translated to this dynamic IP. So the same thing on R6, I'll telnet into 10.3. Who's 10.3? The public address of R3. So I should have gotten translated to 20 dot something. So both my flows are working. And that topology is also done. You guys understand this? So a simple security context and a little bit more complicated because you need to do the physical to logical mapping. Important lab. On what basis traffic is routed to the context? Routing. What's its default gateway? So when I telnet in, I said telnet to 192.1.10.3. So what's my next hop? Based on the VLANs, right, on the switch. This interface over here is in what VLAN? Remember R6, this interface on the switch is in VLAN 10. So when he sees I'm going to a different network, I need to go to what? I need to ARP from my default gateway in my VLAN. And who's in my VLAN? The only device that's in my VLAN is this guy. So he's going to send a broadcast. He's going to respond back because he's 20.1. So he's going to forward the packet to Mark. Mark strips the layer 2 off, says, oh, how do I get to 10.3? 10.3 is reachable via a default gateway. For Mark, the default gateway is R2. Again, VLAN 10, or sorry, VLAN 20. Forwards it in VLAN 20. So R2 strips the layer 2 off, says, how do I reach 10? He would have learned it through R1, through EIGRP. VLAN 12 sends it across over here. R1 strips the layer 2 off, sees the next hop is 10. 10.3, he sends an ARP over here. Sales firewall will return the MAC saying, send it to me. He gets it. He sees 10.3, translates it, says this is allowed, sends it across over here after the NAT. Understood? No? All based on VLANs. And that finishes this portion off.